What I want to do now is prepare to look at simulations that will help us assess how robust t-tests are to their assumptions, and in general, how robust any test is to its assumptions. What do I mean by robust? Robustness means that the method still works out okay if the assumptions aren't true. The method still works out okay if the assumptions aren't true. So in order to do simulations to test the robustness of a particular method to its assumptions, we're going to need some measure of whether the test still worked okay. And what we're going to do right now is gather the intuition we'll need to figure out whether a test worked okay. In particular, here's the question I need to ask. If all the assumptions of a test are met and the null hypothesis is true, if I repeatedly sample from the population distribution or distributions, conduct a test, and write down the p-value. So I go through that simulation process a lot of times. I sample from the population or populations, I do a test, all the assumptions are met, and I write down a p-value. If I do that 10,000 times, I'll have 10,000 p-values, right? If I make a histogram of those p-values, what will it look like? The question is, what is the distribution of p-values? What distribution of p-values would we expect to see? What distribution of p-values would we expect to see if the null hypothesis is true and all the assumptions are met? The reason to think about that question is that we can do simulations where we break the assumptions and then see if the p-values still look the way we would like them to, the way we'd expect them to, if all the assumptions were actually true. So we're going to try to get some intuition about what the p-values should look like if all the assumptions are met and everything is working fine. In other words, if the test is valid, that's the technical term we use. And then we're going to see if that test is still valid. We're going to be able to look at our simulation results and see if the p-values still look the way we'd expect when we break those assumptions in order to test the robustness. Here's the first way to think about this. If I conduct tests repeatedly, if I repeatedly sample from a population and conduct a test, what proportion of the time should the p-value be less than 0.05? If the null hypothesis is true, what's the probability that the p-value will be less than 0.05?